Okay, in chapter 5, we're starting with probability distribution. And with probability distribution, we are going back to like the frequency distribution. Back in chapter 3, we had data-driven, which was like test scores, 24, 26, or ages, whatever, 32, 40, and 45. And you were able to get the mean, median, and mode of those, standard deviation, and then you have frequency distribution. And that was 20 to 24, 25 to 30, or 29, 30, or 29, 30 to 34, 35 to 39, and then you had the head count over here, which was F, and this is the class, and 2, 4, 6, 8. All right, so in chapter 3, we studied the difference between a data-driven set and a frequency distribution. Now, everybody remember doing that? Finding the mean, median, or the mean and the standard deviation for both. Everybody remember that? All right, well, in chapter 5, we're doing the second part of kind of this same scenario. Only this time, in chapter 4, we had probabilities. You know, we did the probability of A. And then we did the probability of A plus B. And we did the probability of A times B. And we did counting with factorial. So that's kind of the data-driven set that's over here in chapter 3. And it's just called probability. And then over here in chapter 5, we're going to do probability distribution. And the probability distribution is going to be set up kind of like that. Over here you're going to have event. And over here you're going to have the probability. And it'll look something like this. 0, 1, 2, 3. The probability of 0 events happening is 0.1. The probability of 1 event happening is 0.3. The probability of 2 events happening is 0.5. And the probability of 3 events happening is 0.1. Okay. We're going to do some examples and you'll understand what this means a whole lot better than me just throwing it up on the board. But there's some things that you need to look at here, and each one of these is a decimal between what? 0 and 1. So that's your first test. 0 to 1. Each one has to be a decimal between 0 and 1. And the other is that when you add them all up, when you add all the probabilities up, what are you supposed to get? 1. And that's your second test. All of them, probabilities is equal to 1. Now, all of this can be found on page, let's see, what page is it on? Page 196. Here's some examples of probability distribution right here. Now before, y'all remember doing the boy, girl, whatever, all that, you know, the 2 or the 3. In this case, it's two, having two boys. Well, here, you're putting it in terms of a probability distribution. Like that, or like that. And of course, this is your X and this is your P of X. Probability of X happening. 0 boys, 1 boy, 2 boys, whatever the case may be, or in this case, girls. The probability of a couple having 0 girls is 0.25. Probability of having 1 girl is 0.50. Well, that's self-explanatory. And the probability of having 2 girls, in other words, both being girls, is 0.25. And if you did the boy, boy, girl, girl, boy, girl, girl, boy, if you did that, you would come up with these numbers right here. So what they're doing basically is they're bypassing the actual calculating the probability is what they're doing, and that you learned in chapter 4. Before, let's see, what is the probability of having, let me just rephrase that, hold on. Let's say that a couple, and that's what they're talking about in that, has 2 children. Okay? And in chapter 4, we were asked, what is the probability of, well, let's write them down. Boy, 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 girl, girl, boy, and what? Girl, girl. And this is what we call the what? Sample space, or the sample population, or whatever. Or we were asked to find the probability of picking an even card. And you were told that there's 52 cards. There's 13 in each suit. There's 4 suits. And how many even cards were there? I can't remember. Let's see, 2, 4, 6, 8, 10. And then the face cards, that's 5, 8. Was it 8? I can't remember. But anyway, 4 times 8, I'm going to say 8, is equal to 32. And then we did 32 over what? Over 52. And then if we wanted the odd cards, then that would be, the rest of them, what would be 20 over 52. And that would be even and what? Not even would equal 20 over 52. So this is what we did, okay, all boys would be what? 1 out of what? 4. All girls would be what? 1 out of 4. And then the others, 1 of each, would be what? So this is what we did in chapter 4. So what chapter 5 says is, okay, we're going to bypass all this. We're not going to do this. I mean, you know how to do it, that's good, but we're going to bypass that, and we're just going to go ahead and write down event and probability of the event, and then we're going to put 0 girls. What is 0 girls? 0 girls would be what? 0.25. 1 of each, or 1 girl would be what? 0.5. And then all girls would be what? 0.25. So that right there is chapter 5. Now where did we get that information? Right there. See what I'm saying? So chapter 4 feeds into chapter 5. And what are we going to do with it? We're going to find the mean and standard deviation based on this. Just like we did before. Because the mean and the standard deviation drives everything in probability and statistics. Because if you don't know the mean and standard deviation, then you don't know where the middle is. And if you don't know where the middle is, you don't know where your event sits. Case in point, your test score on your Chapter 5 test in psychology or whatever. Sorry. Question. Trying to give you a little bit of an introduction of what we do and where we came from, where we're going. Y'all don't get too excited. All right. So let's look at an example. Or let's look at I'm just going to pull a table up and let's see what we're going to do with it. Because this is giving you an examples. They give you the test. Look, I'll make sure you look at each one. Make sure you see that they are, there it is right there, that each one is between 0 and 1, and that the summation of all of them, this is on page 197, the summation of your events should equal what? Between 0.999 and 1.000. And what they're telling you is that they're going to round to a certain digit, and you may not get 1.000000. You may get 0.999, or you may get 1.001, and that's acceptable. That's what they're telling you. So you need to highlight this right here, or put it in your notes and highlight it, because I don't want you saying, oh, well, that one on the test is not equal to 1, so I'm not going to do it, because you can't. And if it's 1.001 and you say you can't do it, then that's a whole question mark wrong, because you didn't read that little statement right there. And there is, for each individual probability, it's got to be between 0 and 1. Now, I will not give you any like that on the test, but you might get some on your homework. And that's, just to see if you're paying attention. If you get one that's on your homework that is not equal to 1, then you just skip it and say cannot be done. But I usually do not give you those on the test, because I do not want you to get 1.001 and say cannot be done, and it can be done. So, anyway. Now, what if you're not given a table? Well, there is I just showed you how to do it, but they usually do the 3 kids, but I was going to see if they still had it in here, but I don't think they do. Okay, well, we'll write down the formulas. There's the formulas. You need to write those down. I use, and if you don't have a book, I'll blow it up, even though I hate to blow it up. I use 5.1, 5.3, and 5.4. I do not use 5.2. You can use it if you want to. I don't care. I don't use it. So make sure you write down those 3. Now, of course, 5.3 and 5.4 is the same, correct? What's the only difference? What? One is the variance and the other is standard deviation. And what's that relationship? Square root. So they're the same formula, except you have square root in one and you don't in the other. 1, 3, and 4, yes. Give y'all a second to write those down. now that you've had frequency distribution, this should not be a big deal. Let's take, for instance, the first one. X times P of X. Well, that's pretty self-explanatory. You take your event and you multiply it by what? The probability of that event, and then what do you do to all of them? You add them up, Hubert. That's right, class. Thank you for the interaction. Mean for the probability distribution. Take X times P of X and you add them all up. Again, the spreadsheet is a whole lot easier to use, especially if you do it for a certain amount, like 4 events, 5 events, 6 events, and then you just have to type in the numbers and it'll spit out the answer. 5.3 is your variance. I usually don't worry too much about that. I'm focusing on these two, but these two are the same formula, just this one is square root. So I don't really care about this one as long as you can do this. X squared, well, that means you have to set up a column to take the event and multiply it by itself. Then multiply it by P of X, and then subtract what? The mean squared. And that will give you your standard deviation. So from a probability distribution, you can find the mean and the standard deviation, so you can set up your normal distribution and your mean and your 2 standard deviations, so you'll know what's normal and what's unusual and what's an outlier. So the frequency distribution work that you did in chapter 3, it basically got you ready to do this, because this is a whole lot easier, because you only have to do 2 or 3 things instead of 5 or 6. So let's find us one to do. And there's a round off rule also right here. And it says make sure you round at the end of the problem. And you want to, round to the number of decimal places used for the random variable. So pretty much whatever you start with, you end with. If you start with 3 decimals in the probability, then you want to put your answer in 3 decimals. If it's only in 2 decimals, you want to put it in 2 decimals. Kind of like science. Science classes, they usually teach you, they talk about sig figs and all that crap, but usually they end up saying, if you start with the 5th decimal place in the question, then you end with the 5th decimal place in your answer. So, it's whatever, but that's really not a big deal. Not as much as doing the actual problem. Let me see if I can find, here we go. Okay, they give us a table. Where's the table? Let me get out of this. There it is. Alright, here's the table right here. So what I'll do is I'll move it over. And this is on page, take those. That's what you're going to be given. In other words, you're going to be given a chart, or you're going to be told to set up a chart and a probability distribution, whatever you want to call it. All right? And these are what you're going to be given, and they want to know what the mean and standard deviation is. So I'm going to give you a minute or two to do that now that you've got your formulas, and you should be able to take off and do that. I would suggest using columns like they did over here, like the X and the P of X and all that, all that, or X times P of X. I'll use a spreadsheet just for organization, not to say you have to use a spreadsheet. So I'm going to pull up the Excel spreadsheet. And I'll just put X, the event happening, and P of X, the probability of the event happening. And I think this is what we were doing a while ago. 0, 1, 2. Is it 3 or just 2? 2. So it must be the babies again. So 0.25, 0.5, and 0.25. Hopefully everybody can copy it down correctly. And then go to the formulas and ask yourself, what do you need? Well, let's go back to the formula, because whenever you're doing a math problem, it kind of helps to actually, you know, read the formula to see what you need. And I taught you that. I tried to teach y'all that with the frequency distribution. I always get students that come up to me and say, I don't know where to put what where. Well, you need to read the formula. Now the first formula says I'm going to take X and I'm going to multiply it times P of X, and then what am I going to do with that? That summation, what does that mean? Add them all up. So go to my handy dandy Excel spreadsheet, and I'm going to put a column right here that says X times what? P of X. And that's going to be equal to this guy times this guy. And then you copy those down. And then you add them up. And that is your mean. Now, of course, it's not going to always come out to be 0. I mean, 1. But in this case, it comes out to be 1. And now we need to find the standard deviation. What's the standard deviation? Well, we got to take, first of all, we got to take X squared times P of X, and then we need to minus the mean squared. So go ahead and do that if you haven't done it. X squared times P of X. Now that summation goes with X squared times P of X. So you're going to do that first. So we got to take X squared times P of X. So X squared times P of X. Go to your handy spreadsheet, and we've got to get X squared. So I'm going to get X squared. And it doesn't take rocket science to take 0, 1, and 2 squared, but you're not going to always be given 0, 1, and 2. Sometimes you're going to be given 4, 5, and 6. Sometimes you're going to be given decimals. So I'm just telling you, sometimes You just have to take it problem by problem. All right, there's x squared. Oops, got my 2. And then x squared times p of x would be right here. X squared times p of x. So equals this guy times this guy, and copy those down. And then we're going to need a summation of this. So that's going to be 1.5. Now, what do we do with 1.5? After you get x squared times p of x, what do you do to it? You add it up, and then you subtract what? Mean squared. So I'll go down here, and I'll say variance is equal to, and I'll say equals this guy minus this guy quantity squared. And that's going to give you that. And the standard deviation is going to be equal to this guy raised to the what? 0.5 power. And there is your standard deviation. So, now you've been given, and you need to understand what this is, because there's nothing worse than sitting through a class and not even knowing what you're doing. Hopefully you knew what you did in chapter 3 and you knew what you did in chapter 4. So now I need to tell you what you're doing here. Yes, ma'am. Right here. Variance. What do? You take x squared and you multiply it by what? So you take your 0, 1, and 2 and square it. You get 0, 1, and 4. And then you multiply that by the percentages or the decimals. And then you add that up. And it's going to give you a number. Yeah, I think we got 1.5. And then you minus 1 squared. 1 is the mean that you got right here. And then what do you do with the variance to get the standard deviation? You just take the square root. Look at these two formulas right here. This formula and this formula. What's the difference? There is no difference. This is the same as this. The only difference is you take the square root of the variance to get the standard deviation, just like in chapter 3. Does that help? And those are on page 200. Now, what have we done? Hold on a second. This is what we've done. We've taken the probabilities given right here. I'm just going to, I have no idea what the question's asking, but I'm just using this because we did the babies a while ago. 0 girls, 1 girl, 2 girls. From this event, we can extrapolate whatever you want to use, the mean and standard deviation, so we can set up 1.7. What's 1.7? 2.4 and 3.1. And over here, 1 minus 0.7 is what? 0.3. And 0.3 minus 0.7 is negative 0.4. And then negative 0.4 minus 0.7 is negative 1.1. And of course, if you're only having two babies, what's the probability of having 3? None. For pretty much none. Why? Unless you have twins, unless you have one of them, one time you have babies, you have twins, then you can have 3 babies with 2 shots. In other words, the parents are only having 2 babies. Or they only get pregnant 2 times. All right? What's the probability of having 3 kids? Well, is it possible? That's not rhetorical. I'm asking you. Yes, it is possible. It's possible to have 4 kids or 5, because sometimes people have twins or triplets at one pregnancy. So, but is it normal? What's normal? Well, normal is between 2.5, which of course that's not possible. But 2.5 and of course -0.4 is possible. Now sometimes it will throw you some crazy numbers. Okay? Not all the time. This is a small what? What is this? Is it a small sample or a big sample? It's small. So of course it's going to give you some goofy numbers. But this is what you're getting. Always remember, if you don't know anything that you learned in probability and statistics, the 2 most important numbers are what? The mean and the what? Standard deviation. And they will always set up this, which will tell you what's normal. Find the word normal. All right, so that's how you do it. So let's do some. Let me get out of this. Let's find one that they give us in the homework or something. Let me go to the homework and let's pull up one. Well, that's not what I wanted. That's not what I wanted either. 5.2, isn't it? There it is. All right, take a look at that one. Now let me ask you something. Do we still have that copy ability right here? Yes, saves you a lot of what? A lot of time. Try that one. Now what do you need to do to make sure before you start? You need to check each one to make sure they're between what? 0 and 1. And then add them all up, see if they're between 0.999 and 1.001. Do that first. I'd hate for you to waste a lot of time doing a problem that you can't do. right, get to work, please. Wish I could find my keys. I had them in my office the other day.
What's the last number?
They're gone.
0002.
3 zeros and a 2. Do they equal 1? I hope they do. Good.